now. Well, hi, everybody. I'm Kenneth Owens. Welcome to the Monday morning, June 12th meeting of SIG Apps. We have a couple of items on the agenda. So why don't we just jump right in? So does anyone want to talk about starting a KEP for mutable scheduling directives? Okay. No one here to present the topic? All right, we can move to next week. Then KEP 440 controller name.
Yep, that's me. Okay, so hello everyone. I submitted KEP 4040. The purpose of the KEP is to have a unified way of specifying that some other non-default controller should handle a particular API object. Initially, in the proposal, I would love to have support for jobs from SIG Apps and HPA from SIG Autoscaling group, but this thing is generic, so it would be great if we could agree how to handle this type of request going forward. So whether we go with field in the object, or maybe with label or annotation, or what would be the naming here, so that all other requests of this kind could follow the pattern.
So the goal of the KEP, as I understand it, is to allow, disable reconciliation from built-in controllers for an API resource or a secondary controller will be able to
Something like scheduler name, but for other objects. So scheduler name allows you to specify that some other scheduler, non-default one, should handle the pod and apply specific logic. Possibly, I don't know, we'll use some non-standard metrics or schedule pods in a very peculiar way. But so we've got this type of feature for pods. We don't have it for any other controllers, apparently apart from endpoints. And this is the problem, because if you want to provide a custom logic for any API object, you need to disable the controller in Controller Manager. That is possible if you have access to Kubernetes master node. But if you are running on some form of managed environment, like, for example, Google Kubernetes engine, that your options are pretty much limited. You need to fork the API, which is usually a bad idea if you want to have
why is that a bad idea?
To fork an API. And
yeah, so you're going to re-implement the controller from scratch anyway, right? Which I guess, yes, like, stepping back I mean, the scheduler doesn't really control the pod resource, right? Like the scheduler watches for pod resources and establishes node placement. And from the design of the system from day one, the idea of supporting multiple schedulers was baked into the architecture. The concept of how resources worked was always, it was never an idea to support multiple controllers or redundant controllers for the same resource. And it was always like the design, the intention was always to make the resources forkable. So I'm not saying we shouldn't do this, but to say that we shouldn't fork it when, like, if it was like, to me, the arduous portion of implementing your own API is primarily getting the reconciliation logic correct within the controller, right? And then if you're going to say that, like, we're going to do something different to adopt, create using Kubi Builder to generate a custom resource definition and then deploying that into the API machinery doesn't seem particularly arduous for the end user. Writing the controller that reconciles correctly, that's a different story. But what's the benefit to the community of being able to have a third party
Implementation, yeah, sure. So this is not a problem if you are submitting resources manually. The problem starts when you want to integrate this thing with all other systems. So for example, you have a system that submits jobs and looks for job resources, but you would like to handle job in a slightly different manner. Now, either you change this system to support both standard jobs API and your new jobs API, or you allow for example, to switch on some new functionality in job using some method while keeping the API. So the API definition still stands. You need to work within the API constraints, but you can provide a slightly different implementation if that's your need. Without this option, you need to fork the API, provide another controller that is more or less similar to having like a controller name, but then everyone else who uses the API needs to start to adapt to the new CRD and new API group and new API version. And now you
But
have two entities that
that's like kind of intentional. Like I think the things that I see that are really problematic with this approach are, one, there's a set of, particularly for V1 APIs, we have a set of conformance suites which define the behavior of a Kubernetes implementation with respect to how those resources are handled. If we allow for arbitrary implementations of reconciliation logic with respect to those resources, how do we maintain conformance? Like, what does it even mean to be a conformant Kubernetes cluster at that point? So that would be like like a major hurdle. I don't understand. I don't know how we would get over that. And then on the other side, if you have multiple, so if you're providing different semantics at the same API version level, it breaks our definition of version compatibility across releases, right? Like, it means something to be a V1 API. It's not just with respect to how the resources are handled, but with the underlying semantics of the controllers implemented. So if we take a V1 resource and say, okay, we're going to allow you to arbitrarily override the behavior. Yeah, I mean, like, and again, from a Kubernetes standpoint, like,
you can do it right now. If you disable controller, you are free to do it, right?
Right. I mean, if you disable a controller,
only if you have access to the master. If you don't have access to the master, then your options are limited, and then that's the problem.
But it's different. There's a difference in semantics between saying, I'm going to disable this resource entirely, and when this resource is applied to the API machinery, it will not be reconciled, to I'm going to allow for different versions, for the same version of the resource to have varied semantics depending on how the machinery is. And maybe the annotation is enough, but I just see those as two kind of hurdles that are like not addressed in the KEP.
Okay, I can expand it to address it. And apparently, like, someone pointed that there is already a prior art for endpoint slice. And it uses like a very custom specific name for that annotation. So,
but endpoint slice doesn't have multiple controllers. Endpoint slice is a different API resource. So the limitations of endpoints precluded us from, basically it was a scalability limitation that Tim always wanted to address. So when we introduced endpoint slices, we introduced a completely separate resource. In fact, we didn't like override it and say you have, and then, there was a whole upgrade policy inside of the cluster in order to release that resource to make it generally available, have all of the other components. So it's maybe somewhat anomalous, but it's certainly not like we put a switch in and says like, okay, like there's the whole thing we put in for the conversion so that you could retrieve an endpoint slice as an endpoint object to maintain backward compatibility and vice versa and convert them. There's bidirectional conversion, but that's API resource bidirectional conversion. It's not deploying a different operational semantic via a reconciler under the hood, right? Which is what seems to be proposed here. Again, like, I'm not like, if we did this via annotation and then we released it generally, it doesn't prevent users or the community from developing and building a conformant cluster. But kind of semantic conformance and then versioning and handling of resources and what it means to be V1 or be V1 beta 1 in terms of what the promise is to the community, like that that has to be addressed in some reasonable way if we're in my opinion, if we were going to consider this.
Okay, So you're basically saying that I need to describe like what does it mean alpha and beta API in that case?
Not alpha, V1. So alpha is
so
like,
maybe
yeah, alpha is experimental and at this point off by default, right? So if you're using alpha features in your cluster, like you had to explicitly enable them in opt-in. Beta,
okay.
like beta level stability has to like go to GA relatively rapidly given our new, but our promise around V1 is that once you go V1, it's stable and backward compatible, and the semantics of the resource and the implementation are stable and backward compatible until a V2 is released or, yeah, right. So if we're going to say like, well, now we add an annotation and it completely changes the semantics of it, maybe that could be a thing, but I mean, that's very, very different from the promises that we've made to the community so far, right? So like, I mean, like there's got to be a discussion, and I would definitely want to pull in API machinery because they particularly like, I mean, every SIG has been a participant in conformance, but API machinery has kind of really driven it, and they also really care about, they have a vested interest in that as well. So I'm willing to pull them in as a side just from SIG apps and SIG auto scaling.
Okay, okay. Should it stay in SIG apps or should it move to SIG API machinery?
I mean, like a SIG apps will definitely be involved if the primary resource that you want to target is job, right? Because the batch workload lives here. But if you're also looking at auto scaling, you would want, SIG auto scaling or cluster lifecycle. Is that where they're housed now? And then
No,
yeah,
SIG
like
auto
this would
scaling.
probably be,
HPA is SIG auto scaling.
yeah. So this would probably, I imagine this would be like SIG architecture, right? Like you're saying like we're going to change kind of a fundamental principle. And again, like I'm not saying we shouldn't, but I'm saying like we definitely have to proceed carefully if we're going to implement a mechanism to allow multiple. Well, I guess like the way it's proposed here isn't simultaneous, right? Like you would have one or the other, or would it be could you have potentially simultaneous implementations in the same?
Like you can have multiple schedulers and identify it with scheduler name. You can have the default one and you have your custom one. Here, if the proposal goes in this form, you could have like the default controller and the custom controller that should still operate within API definitions.
Yeah, I imagine it would be SIG architecture if we're making a fundamental change to the architecture of the entire system as well, right? Like we're saying here, now we have multiple reconcilers for API resource, which I mean, you could always kind of do that. You could always try to chain them, but because like there's nothing saying that you can't have multiple controllers watching the same resource. So you can only have one owner, right? And that's the other thing, like the owner reference for the controller. There's a lot here that's it would be substantial work, and it's like I mean, I like that it's a big idea. Like I'm not opposed to it, but I think it has to be thought through a little more than just saying like this is like the scheduler, because it's quite a bit different.
Okay. Thank you for the perspective. I haven't thought about it. So I will add the section that you described and engage SIG architecture and SIG
Yeah,
API
let me
machinery.
ping. There are a couple people I can ping on it, and yeah, I would like to see what Daniel thinks about this, maybe even what Tim thinks about this as well. Because this is kind of a big shift. But I do get the use case, right? Like it's like I want something like Volcano, and I not only do I want the scheduler to behave differently with pods, but in terms of the way that the job itself and the resource is handled, I want something I want to be able to plug in, right? And that is kind of a compelling use case too.
So when we have scheduler running, what do you mean by like both the schedulers are going to be in place? So is it assuming that only one scheduler is going to act on the pod? Because that is how, if I remember correctly, if you specify the scheduler name and the pod spec, only one scheduler is going to pick it up. If not, it's going to be default scheduler. Or are you thinking about chaining as
no chaining? Sort of so rather okay. Like you specify it just like you scheduler, no chaining.
Yeah, chaining works today, right? Like there's nothing that stops you. The built-in controller would inject the controller ref and act as the owner for the object, right? But you can have multiple reconcilers acting on the same object. This is more like we're going to have multiple potential owners, and then some annotation or some API mechanism that declares that a resource should be owned by. Yeah, there's Hiba. There's a KEP. It's actually linked in the meeting minutes. It's KEP 4040 called controller name. But yeah, so that's yeah. I mean, it's ambitious, but we just got to think through.
Yeah, I agree. I think.
Yeah.
I think we wanted to do something similar, but most of the folks that I've seen are forking the API and then building their own controllers. It's not bad as such, that mechanism, but we have already defined a particular life cycle for the objects that we are interested in via the controllers. So if we are trying to be conformant, or if we are saying that we are going to allow non-core controllers to act upon the core objects, there has to be some way to say it is not going to be conformant anymore. Like the distro is not going to be conformant anymore. That is where I think I would draw the line.
I mean, pretty much, but it's kind of interesting in the sense that like you're literally saying I don't want to be conformant at that point too, right?
Exactly,
because
yeah.
if you implemented, if you had I mean, aside from like perhaps you could do something like I'm going to implement a conformant deployment controller, but I'm going to do it in such a way that I get a performance benefit, right? So it passes the conformance suite, but it actually has better performance, right? Like, you know, I could see benefits to diversity of implementation for sure, but it's a very different way of what the community has been directed to do before. Like from day one, it was always like, we wrote these things to be forkable. Please fork them. At some point, we want to evolve to a place where the built-in resources are no longer special, and that all resources are kind of just resources, whether they're, you know, part of conformance or whether you're bringing your own. But, you know, it very much is like, there will be one kind of controller that owns a resource, particularly for workloads controllers, and you can chain as many as you want. But if you want to change the fundamental behavior, you know, go experiment, fork the controller, fork the API. If you find something that's valuable to the community as a whole, then, you know, we will be happy to take it and upstream it into the built-in resources, provided we can do so without breaking backwards compatibility.
I think at some point of time in architecture, we wanted to have not too many controllers within the code or too many APIs within the code, right? So wouldn't we be going against that principle at that point of time, where everything has to stay in the core KK Kubernetes repo?
Indeed, the entire purpose of custom resource definitions was to just one day have resource definitions and to minimize a step that were built in and allow people to kind of choose their own journey with the resources that they put into the cluster. And that would be both, you know, providers of Kubernetes distributions as well as end users, right? So it is kind of, yeah, not the way. But I mean, again, if the community at large feels that there's value in it, I'm not going to say like, you know, and we can find a story about how you can do this in a way where conformance still makes sense, where API versioning still makes sense, and where the end user of a cluster can be confident in what they're getting when they deploy. Then, you know, it's not, you know, the reason we shouldn't consider it at that point.
Makes sense. I think would a good starting point be something like we are still going to be conformant. By that, what I mean is we are going to honor the life cycle of whatever the workload controller, whatever the workload is, which is maintained by the controller, and say that having an annotation or a particular field, and let the new controller that is being created be conformant with what we have had in the past or what we have currently. Would that be a good starting point?
Yeah. I mean, I don't see why not.
Okay. Yeah, that's all I have. Thanks for this discussion. We want to do something similar, but we were trying to figure out what is the best way to do things like this.
The advice I would give anyone if they came off the, like just today, like I want to implement custom functionality in Kubernetes, it would be, okay, like I would point them probably at the Kubi Builder book and say, you know, this is how you extend the API machinery by adding custom resource, and this is how you add a custom reconciler into the cluster, and here's how you can do it for cluster scoped resources as well as namespace scoped resources, and all the things there, because there's a lot of prior art. This would be maybe something one day, if it evolves, that we could point them at too as a different direction.
Okay.
Did anyone join who is, all right, does anyone else have anything on this topic?
Yes, I have a topic that was added to the agenda by Aldo. So, but I was a little bit late, so probably that's why you started.
No, I saw you jump on. I was gonna go back to the prior topic that we missed before, but I want to know if anyone else had anything on this topic before we move back.
Yeah, just want to add that like some of the CRDs are already doing this, like that they have one type and they have like an annotation or label, and for example the Postgres operator has it, so you have few Postgres SQL objects, and you can specify a controller which will control this resource. And I heard also from our monitoring team that they would like to know if it is possible to have like define this somehow on API level, so you could like expect the same like for other CRDs, that if like that you could always know if there is a controller which controls this or not, and you do not have to search the exact implementation of the thing to know that you have to search for this annotation. Or for example, if you would have only a certain annotation, or for example something in metadata that would control this thing. So like I think this could be like a point for discussion if you decide to go further with this.
Yeah, sounds reasonable. Okay, are we ready to move back to mutable scheduling directives?
Yeah. Okay, so if no further comments on the previous topic, then I will present. So basically, this is a need that came out very recently, so we don't have yet a draft cap or anything, but just want to collect like quick feedback. So this is also needed for batch and specifically for queue. So queue has the ability to control job lifecycle, so it can stop, or we call it suspend a job and unsuspend. And also queue assigns node selectors. So queue, let's say, decides, so user creates a job, and then queue is injecting node selectors on the moment of unsuspending, like starting the job. However, and then when it suspends back, it restores the original user node selector. So this is like for context. However, what we experience is that the suspending of a job is a little bit problematic currently, because one is performance, and second point is the trickery of the API. So we would like to improve on that. So let me explain. So when we suspend a job, currently 3 operations, like 3 requests, the external controller, like queue in this case, needs to send. So first of all, it suspends the job, but it also needs to reset the start time, and this is the tricky part, the trickery in the status, but start time lives in the status. And only then it can restore the node selectors. And this is 3 API calls, so one is overhead, but also this trickery, and we would like to improve it. So the idea is that the first point of the improvement is that you will be able to modify the pod template in job on the suspend call. So when you're suspending, at the same time, you can already inject the node selectors. And this is currently, I think, blocked. And yeah, that's That's the main thing, but there is also another regarding the start time. Okay, because the job is already started, so you cannot. So the job is already started, let's say. So the start time is not nil. Then the scheduling directives says that you can mutate the node selector, but it's only available if the start time is nil. So that's why Q does like first stopping, then resetting the start time so that it can, in the next step, suspend. And this is like problematic, and that's why we came up with this idea of relaxing this. So we will allow modifying the node template even if the start type is not nil, and this will allow to do the suspend and the restoration of the node selector in one call. Potentially, and here it is mentioned by Aldo, that one problematic case is that when you suspend, the pod with the old template injected by Q or modified by Q may still be terminating or are still essentially running for a while. So then if a user or the external controller like Q unsuspends, then you may end up having two types of pods with different, at the same time, living. And the proposal to solve this is that job controller would wait until all the pods with the old template are deleted before creating new. So there is a little bit of trickery to solve the race conditions. Yeah, but in general, we would like to maybe get some quick thoughts if this is the way to go, or how otherwise to improve the API so that there is no this. Like this is like a more of it's still vague, but it's a proposal. But in general, we would like to from the bigger picture improve the API, so you don't need to issue these free calls and yeah, and do status update in Q. I don't know if that.
How would you make it mutable?
Sorry?
How would you make the node selector mutable? Because it sounds like as far as I know, node selectors on PodSpec are only mutable in an additive way. Like you can add additional nodes, but you can never remove a node from a node selector, and you can never mutate the node value. Like basically inside of API validation for core objects, there's no way you could modify the node selector.
Oh, so we do allow for that, and this was probably already introduced for job. So we have this. Okay, but
you're going to mutate it on the pod template spec. You're not going to mutate it on the pod itself.
Yes.
Okay.
Yes.
All right. And then the pod will be down. Okay. Yeah. I mean, okay. Never mind. I get what you're saying.
So in job we embed the pod template, and this is where we allow to modify.
Yeah, you allow mutation of the pod template spec, but you don't expect that mutation to propagate to a running pod. You expect that since the job is suspended, when you unsuspend the job, you would create a new pod, and that pod would match the node selection specification in the pod template spec, right? Like you're not trying to mutate the node selector of a running pod or a pod that's in any way scheduled. Yeah, okay, that makes more sense. Yeah, okay, I get you.
But then it's a question of how problematic it is that like two types of pods will be running for a while. So let's consider now the scenario that you suspend the job with the old node selectors, then you unsuspend. So there are like different set of selectors. So if we don't wait for the old pods to terminate for a job, then it means that the job owns pods with the old for a while, with old and new. And then the question is, should we wait until all the old pods are terminated, like deleted? I guess the Aldo suggests that we should to avoid confusion, but I want to also check
It
with.
depends on what the semantics you want are, right? Like if you're going to wait, like, so how long would you wait for? Because you can't, well, all right. So if you're going to wait till they're terminated and like there's an unintentional disruption and the node is gone altogether, you may have to wait until that node gets evicted from the cluster in order for that pod to be like, you know, effectively, that wait could be substantial, right? If you're going to wait under normal operating circumstances, that seems reasonable as long as the guarantee you provide to the end user is that, you know, this is kind of a best effort. And in the event that the waiting part is tricky, if you're going to allow for some degree of temporary parallelism, whereby you have like a terminating or potentially running pod that needs to be cleaned up later on a different node, and you've scheduled one, like what's the implication of that? Like, why would that be bad? Is it just a resource consumption thing?
I think so again, that's unfortunately Aldo cannot be with us, so I'm like on behalf of him. So that's what I'm thinking. But I think his issue was not with so much with the resource consumption, but more with user confusion. Let's say that you can have, but maybe that's not a big deal.
Does it, well, I guess, is it for job or for index job, right? Like if it's an index job, I'm like if you're using this to schedule MPI jobs where the index is really important, I can understand precisely why that would be problematic, right? If you have job 0, if you have 2 job 0, but there are other fencing mechanisms in that case to prevent it, as far as I understand. I'm not an index job expert. If for job in and of itself, like parallelism has always been to some extent best effort, right? Like we try to eventually get there. So, you know, if it's temporarily not the exact parallelism that's in the user's declared intent, that's not the end of the world from my perspective. But I am also not entirely sure I get, yeah, I probably need some time to like dig a little bit deeper into exactly what you're trying to achieve. Because it doesn't sound like either option is horrible to me, right? Like it sounds like this is kind of like what semantics do we want and what is the best. Like if you did either of these things, I wouldn't be like, well, that's horribly wrong. Like it's kind of ambiguous as to what the right thing is.
Okay, cool. Yeah, I think that's what we want at this point. So we just want to solve this problem, and like probably we need still to draft the cap and go through review, etc., discuss different options to define the semantics best. But just wanted to mention in terms of, you see like some problems with this, like more fundamental. But if not, then.
And then, are you saying that well, the only problem I would see, it's actually, that's not a problem. So, and you know for a fact that the node selector, we don't validate immutability of the node selector on the pod template spec of a job. Like we already allow the mutation.
We do allow mutation under certain conditions. Okay. So when we suspend or unsuspend the job, so when we make the transition so that Q can inject or restore the node selector, but when suspending, we also require that the start time is let me check. Yeah, yeah, when suspending, it also requires that it wasn't like started yet. So if you have a running job, then that's why we need to do the trick currently.
Okay. The only concern I would have, and it doesn't sound like we really have that here, is that so like if let's say it was 100% immutable to begin with, and then you want to make it mutable. In the past, the API reviewers have said that that's fine, right? Making an immutable object mutable doesn't represent a backwards incompatibility, because if you couldn't mutate it before, but now you can, people weren't depending on the mutability. However, changing the semantics of the mutability has to be done in a backward compatible way. So in general, you can't make it more restrictive. So if you were allowing mutation of a particular type before, you can't make a breaking change into a subsequent release that makes it more immutable or mutable in a different way, right? You can make it less immutable. You can allow different types of mutation, but you can't, make the mutation more restrictive or disallow it after that point.
Yeah, so we want to relax the validation. So essentially do not require the start time to be nil, so that the user or the external controller doesn't need to issue the interim call to nil the start time.
Right. And that seems reasonable. That doesn't seem like it's like super problematic. I mean, you could open a cap it wouldn't be a bad idea to open a cap just so that like all of this is captured and we demonstrated that we talked it through. But I would expect it to be like not controversial and relatively fast to get through.
Okay, cool. It's still just like a couple of days till deadline, so we'll consider if we have capacity. But yeah, it's good to know that.
And I would also defer to Aldo too. Like if Aldo's like, I don't think it needs a check cap, I prefer to handle an issue. That's fine.
Okay, cool. I think that's exactly what we wanted to get as feedback for now. Any other comments or questions? Okay, thank you. So yeah, I guess we'll just proceed with drafting the cap and we'll see if we have capacity for 128, otherwise for 129 probably.
Okay,
thanks.
good. All right, those were the two discussion topics that we had for today. Is there anything else that we would like to discuss, or would people like to get 20 minutes back? Okay, I will take silence as we have nothing else to discuss. All right, thank everyone. Thank you all for attending and contributing. We'll see you during the next meeting, and have a happy Monday and a good week.
Thank you. You too.